Tonight, I'm going to share with you some fascinating things about sleep. We all know that sleep's important, and but until recently, we really understood very little about it, other than that you spent about a third of your life unconscious. That's quite a few years of your life to not be there. And, at first you look at it and think, well, sleeping's a waste of time. But of course, anybody that's gone without sleep, realizes that it's not. It's very essential. But recently, within the last decade really, they have done a lot of research that's really given us an insight into what's happening inside the brain during this time of sleep. Sleep is not doing nothing, even though to us it seems we're doing nothing. It's like, I can sleep and I'm out of it, and you don't realize your brain never sleeps. During what we call sleep, our brain is extremely active. It's just doing different things, very essential things. And apparently, in God's scheme of creation, that's the only way to make things work right, is to have sleep. Because not only do we need sleep, but every other creature we know of needs sleep. Birds, fish, whales, insects, little things in the sea. Which just this last week I was reading spiders. These jumping spiders will make a little web, hang down upside down from this little web, and sleep. And because of the movements and stuff, they actually measured the spiders are dreaming. Now what's the spider dreaming about? A fly or a bug it's going to catch? I don't know. Or is he having a nightmare dreaming about some human coming after him with a fly swatter? I don't know what spiders dream of, but they actually were dreaming. In other words, somehow there's really essential. And we're going to take a look at some of what that essentialness is. But if we go without sleep, what happens? We know that sleep deprivation really damages the body's immune system. And I'm not talking just about total sleep deprivation. I'm talking about not getting your full 8 hours. Somewhere between 7 and 9 hours is pretty much what the human needs for sleep. Bats get the most sleep of any creature. They're only up for 3 or 4 hours, and then they sleep the rest of the time. The immune system depends on sleep. It's during sleep that it's regenerated and functions properly, and without the sleep it doesn't, making us much more susceptible to infections. The immune system also protects us from cancer. People who get less than 6 hours of sleep double their risk of cancer. It's Alzheimer's disease. A good measure of someone who's going to go on to Alzheimer's is someone that isn't getting adequate sleep. We find out that that's one of the factors in there that's key. Alzheimer's is multifactorial. It's like, we now know about 30 things that contribute to it or protect from it, depending on how our various lifestyle habits. But sleep is a very key one there too. Someone that's not getting their sleep regularly is someone that's probably getting down that road to the Alzheimer's disease there. Coronary artery disease, the number one, again, sleep deprivation is going to significantly increase your risk of coronary artery disease. Insulin resistance, diabetes, type 2 diabetes, which is 95% of all diabetes, is affected by sleep. They did a very interesting experiment. They took a bunch of healthy college students with no diabetes or anything going wrong, and they put them on 4 hours of sleep per night for 1 week. By the end of the week, 100% of them were measuring in the pre-diabetic range on their glucose levels. In other words, they can't seem to control their sugar unless you have adequate sleep. Very fascinating. So it not only shows your ability to handle sugars, sleep can determine what you choose to eat. They took, again, healthy college students, and they tested them in a sleep lab, and then they would come out, and when they finished their sleep cycle, they would bring them out. In this room, they had 2 big tables set up there. And one table was all full of really good, healthy, what we would call a full meal, type food. And the other table was set up with what we would call junk food. There was donuts and coffee, but it was full of all kinds of rolls, sweets, but it was basically all empty calorie junk food, and the other one had, healthy fruits and, different things, omelets, and I don't know what all they put in. But anyway, there was healthy versus junk food. And when they would give them a full 8 hours of sleep, and then they would come out and they could, get whatever they wanted to eat, they almost all chose the full meal healthy foods and really didn't seem to go after the junk foods. They did the same thing on the sleep deprivation of only 4 hours of sleep, and they almost all went over for the high carbs, the sugar, that type of stuff, and we're just loading up on the junk food because of the sleep deprivation. There's hormones in the body that control how much we eat, ghrelin and leptin. Ghrelin comes from the stomach, and when the stomach is empty or full, depends on how much ghrelin it puts out. But basically, ghrelin says, hey, your stomach's empty, it's time to go eat. The other one, leptin, it comes from the fat cells in the body. And basically, if you've got a lot of fat cells, you put out a lot of leptin, and the leptin goes to the appetite center and says, hey, we got lots of food storage, you really don't need to eat that much right now. We're good, just, hold that guy. And what they find with sleep deprivation, the ghrelin goes up and the leptin goes down. So you've got both things saying, go eat more. We need reserves, we need to eat, your stomach's empty, let's go for it and eat. And sleep deprivation pushes obesity. It's just one of those things there. And of course, sleep-deprived sleeping, that micro sleep that happens when you're driving home from a night shift, or if you've been up all night, whatever, and now you're trying to drive to work. I know of one nurse that works with us, had a bad crash and was on the way, home from a night shift. I know of one of the paramedics there in our town right there. He was coming after a night shift, driving his pickup and head-on collision and didn't survive. I spent 36 years in the ER and quite a few night shifts, and I know sometimes those mornings after being up all night, you've got micro-substitution, you're driving, and you're kind of, because your body is trying to shift into sleep, and you're trying to, as hard as you can, to stay awake, turn, the radio up loud, open the windows to get cold air on you, and kind of stop, you need to kind of stay awake. Because it's just, your body's trying so hard to slip into a sleep cycle. Even moderately, sleep deprived, lessens the reaction time and makes you more likely to drop into some of these micro-sleep things. Missing a night's sleep is the same as being intoxicated with alcohol. So what is sleep? we now begin to understand much more of what sleep is. And I'm going to go through and show you some of what we've learned in science, both how the brain goes into sleep and actually what the brain is doing during the sleep. And that is particularly fascinating, I think you'll find. Your brain has a circadian clock. A clock, it says circadian, about a day. Circa dia, about a day. And there's a little center in your brain there, and they've got a picture of it there on the screen right there. Let's see, right there. That is the clock in your brain. And they've enlarged the picture of it here, and here you can see the different kind of cells in it. The cells that make up this clock have proteins that will build up and degrade over, they just said, this oscillating cycle that is about a day's length. Most people, and you get the average of everybody, it's about 24 hours and 15 minutes, so it's a little bit over. And you keep resetting it to sunlight. You know, when you have a clock that's kind of off a little, if you reset it once a day, you could pretty much keep it synced to what it's supposed to be. And our clock is synced to light. In the eye, inside the eye, if you take the retina back here, the retina is the very back of the eyeball. Everything out front of it here is the optics. The lenses and even this vitreous kind of jelly-like material is part of the lens. And all of that focuses the image back here so you can see. And the retina is the sensory cells, and they go back down the nerve there. If you took a piece of this, a little piece of this retina here, and expanded it and looked at it under a microscope, here in the very back part, the light goes through here, and these are the rods and cones. That is probably what you're familiar with. The rods are for fairly dim black and white vision at night, and the cones in brighter light give you color. And between the different cones, you get your full color of everything you look at. And all of these go through various nerve tracts and end up going back to the back of your brain, and that's where you see. But besides the rods and cones, as most people know about, there's a whole nother set of light sensors in your retina. There are these little cells up here called ganglion cells. And the information, the light sensing from these ganglion cells does not go back to your occipital cortex, and it has nothing to do with seeing. Instead, these little signals control, they're kind of an off and on, bright and dark type of a signal. And that light signal comes back here to the pineal gland, the suprachiasmatic nucleus. This is that little clock center. And they set the clock. Every day when the sun gets bright and it gets daylight, you're resetting your clock. It's daytime, it's light time, and that way you keep synced on that. And everybody is synced for the daylight time zone of wherever they live. You know, whichever side of the world it's on, that's where their clock is running, so that it knows now it's daytime, now it's nighttime, and it runs through this daily cycle here. This little clock has little nerves that have connections. They go down to some little things down here, some up here. Eventually they come back to the pineal gland. And in the pineal gland, we take serotonin and make it into melatonin. And during the day when it's bright and sunny, you will start making serotonin. Serotonin is that makes you feel good, relaxed, calm. It's the opposite of being anxious. Serotonin deficiency is depression. And so serotonin is the natural antidepressant in the body. Now, many of the antidepressant drugs are trying to change the levels of serotonin in the body. Because if we get the serotonin levels up, we're not depressed, we feel good. I mean, we're down here at the beach. If you spend your time out during the day getting a lot of sunlight in your eyes, you're probably going to feel really good compared to if you lived where there was very little light coming in. But at nighttime, the serotonin gets converted into melatonin and released in the body. This is just showing some of the complex other circuits that come from those special sensor cells that do not go back to the occipital cortex. Not only controls the pineal gland, your eye. When you're in bright light, you notice how the pupil of your eye cuts down very small. And then when you go in dark light, it dilates. That's these same nerves. They have some different little centers here that they go to. Then here's some here that will actually send nerves back here and controls the iris in the eye. Isn't it amazing how God made all these little circuits and know just what to do to make them all run, and you got the right sensors, and you know. This I didn't put on to confuse you, but this kind of shows from the retina to this clock. Here's your clock center here, here's the pineal gland here, all these other little centers. But if you look at these arrows between them, see all these little abbreviations? Those are the various neurotransmitters that are used in those nerves. There's GABA, that's the one that's affected, and they can be affected by different drugs and medications. The anti-anxiety drugs like Valium and Ativan, those affect GABA. There's ones that are affected by opiates, if you're on opiate pain medication. There are ones which are affected by different hormones. There are some that are affected by acetylcholine. And it goes on and on. All of these different little norepinephrine, epinephrine, there's all of these different ones. And now we've got drugs to kind of manipulate some of those. Well, if you think about that for a minute, if you've got all of these complex circuits, and you take a drug to kind of affect one of them, okay? So say we take an SSRI like Prozac because we want to be not depressed. And so they prescribe one of these SSRIs or SNRIs, which raise serotonin levels. And so the serotonin levels, but they don't just at one or two little centers. They do it globally. Every single neuron that uses serotonin gives it serotonin boosted. Suddenly, all these complex circuits, and we're just beginning to understand them. The brain is extremely complex, and there are thousands of different little centers, each doing a little job. Suddenly, they're all going to be off by having extra serotonin in them. And sometimes it's a very delicate machine, and when you start just plastering it with these drugs, yeah, you get this one effect, but why do all these drugs come with so many side effects? Because they're also affecting this one, and putting this one up and this one down, and blocking this one, and it's just, I just wanted you to get a picture of how complex the brain is, how delicate it is, and how drugs can really mess with all of that delicate complexity that God designed in there. Back to our pineal gland here, putting out melatonin. If you look here, this little graphic kind of shows, here is time. There, they've got 24-hour time here, and your melatonin level here. So your melatonin level is coming on here. And around 8 o'clock at night, it starts putting out melatonin. And it gets higher and higher and higher and higher here. You know, by the middle of the night, you've maxed out your melatonin level there. Is on, and then it drops off. By here, they've got 7 in the morning. You're back down to this low daytime level. The melatonin basically is sending a message to the neurons in your brain, go to sleep. Now it's time for sleep. They don't actually cause the sleep. There's another substance called adenosine that does that. But they're sort of like giving the signal. You know, at a race, there's somebody at the starting line with a little gun. On your mark, get set, boom, go. And it gives the signal, and then all the runners start running. Melatonin is that signal to your brain. You know, when the melatonin level starts climbing, hey, you're feeling it's time to go to sleep, get ready for sleep, we're switching to sleep. And when the neurons switch from awake to sleep, a huge change takes place in the brain. And we're beginning to understand a little bit about what takes place during this other state that we aren't aware of. We become unconscious during that state. Here it's showing the melatonin levels and the day and night cycle here. When melatonin is up, cortisol is down. Then during the day when it's down, the cortisol goes up. Melatonin is sort of the director of the orchestra of all of the other glands in your endocrine system that put out all of these other hormones in your body. Your thyroid hormone is on a circadian cycle. Your cortisol levels, all your adrenal things are on a cycle. And so with most of the other hormones in your body, they come in a daily cycle. There's times when they're really high and there's times when they're really low. Melatonin is what keeps them all working together. So they're all doing the right thing at the right time. If you think of an orchestra, if everybody put in earplugs and didn't watch the conductor and just started playing his piece of music right there, what would it sound like? Pretty soon, it would be just totally off. By the time you got to the end of a symphony, it would be so off. It would be. But you not only listen and you watch the conductor, and the conductor is bringing everybody down the beat by his waving his baton and everywhere. Melatonin is that conductor that keeps all of the parts of your body synchronized in this daily rhythm where it carries on the various functions that you want it to carry on. Your body temperature drops down at night. Again, melatonin, as the melatonin level peaks out, your body temperature drops off. Like most things in life, as we get older, they don't work as well. And this little graph right here is melatonin levels during the day and at night here, during this dark band here. But the different lines here are age. This big high peak right here is little children, 5 to 10 years old. They have fantastic melatonin levels. And you know that phrase, sleep like a baby? Hey, they are super sleepers. And they've got those big melatonin levels. At puberty, there's a significant drop. And as that drop comes in, it's that drop that is actually signaling the testicles and the ovaries to start putting out testosterone and estrogen and begin the puberty cycle. So melatonin even is affecting that on a, you might say, lifetime clock right there. Now is the time to grow up and become a man or a woman. And it does that there. Here by 40 to 50 years old, it's dropped down here. 50 to 60 here. Over 65, we're way down here. As we get older, it's harder to fall asleep. It's harder to deal with that. I don't think God meant for us to get old and disintegrate, but that's part of life on this earth, the way we live it now. But as we now understand, this melatonin is a very simple to make, or actually it's even found in nature naturally, you get it. And so it's very easy to take a melatonin supplement at bedtime and push our melatonin levels back up here where they should be for the night cycle. You know, a rapid acting one will push it up right here, help you fall asleep, but they make some sustained release versions that have a 6 or 7 hour release cycle, and they'll keep it going here for your night cycle, and the combination of those two can really help you if you're, starting to notice that I can't seem to get asleep or stay asleep like I used to be able to. So as we get older, supplementing with melatonin right in here can be very helpful to restore levels back to what God always designed they should be.
Wow.
Very interesting aspect. Adolescence have a phase shift. Like if here, this black line here is the normal cycle that we use at night. Our teenagers here have a much later phase shift. In other words, they're not ready to go to bed. They want to stay up late. It's just naturally they're wide awake. They're not ready to fall asleep yet. And they might have a much later one. And of course, in the morning when it's time to get up, who's the sleepyhead in bed and doesn't want to get up because they're on this late cycle right here. And by forcing our young people into this, you might say, to fit the adult world sleep cycle, we're actually doing them quite a disfavor. Our school day, you got to get up early to catch the bus to get to school on time down here, and you don't have time to, you need a couple of hours extra sleep cycle here. You know, and it's going to be normal for them to stay awake, and if you force them to go to bed, they're not really getting into their sleep cycle yet because of the melatonin isn't coming up there. Interestingly, there was a school district that decided they would try to actually be physiologic for the kids. And the very earliest they started was around 9, and a lot of the classes started around 10. Well, what school do you know that does that? But this school did. In other words, they were allowed, given the opportunity to have the normal sleep cycle there and get to school what we would call late, but that's when it started. And interestingly, everybody's grades went up. The SAT grades and the PSAT and the ACT test all went up significantly. You know, all the measures you could say of their scholastic ability went way up just because they got their sleep. Sleep is so essential for learning, and it's just, sleep is not nothing. Sleep is important, and what happens in that sleep cycle. And if for our teenagers it happens then, we should be adjusting what we expect of them into, just as we want them to choose the best food, we need to give them the best sleep. And their best sleep is going to come a couple hours later than everybody else's. Okay, so what is the, now this is a really fascinating part here. What is the brain doing while it sleeps? And there's different phases of sleep here. And this little graph right here, I want you to take a good look at this. And we have right here at the top here, awake. This is the awake state of the brain. And there's several different stages of sleep. The nearest to awake is what we call REM sleep. REM stands for rapid eye movement. If you've ever watched a baby or something when they're sleeping, a lot of times it's like their eyes are balls darting around underneath their eyelid. And this REM sleep, the eyeball is rapid. We still don't know why the eye does that during REM sleep, but it does. REM sleep is when we dream. And then there's deeper levels of strains. These deeper levels here are called non-REM sleep because we're not having rapid eye movements there. So that's kind of like a REM sleep and non-REM. But the non-REM comes in stages, and they've divided it up in 3 or 4 stages here where it drops down into deeper and deeper levels. And you notice it comes in cycles here. Your brain will go through 4 or 5 cycles every night of sleep. And those cycles are about an hour and a half long, 90 minutes. So you'll go through these 4 or 5 cycles, and each cycle is about 90 minutes long. And when it starts off, we almost immediately start dropping fairly rapidly down into this very deep sleep right here. And we'll go through a cycle of that and then come back up and then go back down for another cycle that will go down really deep. Later on, during the night, we don't go as deep in those really deep delta wave 3 and 4 level sleeps down here, but we start picking up more REM sleep now. And then the last sleep cycles here in the morning, before we get up, is almost always mostly REM sleep. And there's some of these stage 1 and 2 here. And these stages, right, this is where all the dreaming is. You're on and out of dreamland, is about getting time to wake up right there. Of course, if we set an alarm clock for our kids and they get up here, what happened to their REM sleep? Well, REM sleep is very important, as you'll see as we go along here, but we need that REM sleep and we need this deep sleep here. They measure the brain waves, and here's about what it would look like if we saw what's going on here. This is what an awake brain looks like on the EEG there, the awake brain cycles there. What they call alpha waves, a drowsy, relaxed sleep. It's kind of a very relaxed, meditative, but awake. Your brain waves are here, what they get into these, what they call alpha patterns. But then as we move into sleep, that first level here, this is the REM sleep. And they're almost impossible to tell from these awake sleeps. And if you think about it, well, that's when you're dreaming. But some very important things happen during REM sleep when you're dreaming. Down in the thalamus, in the center of your brain there, where all of your sensory comes in and your motor nerves go out, there's like a switch. And when you go into sleep pattern, we switch off the sensory input and we switch off the motor output. If you think about it, you need to switch off the motor output. Otherwise, when you're running in your dream, you'd be up running around, sleepwalking, doing those kind of things. Punching out the person next to you, depending on what you were, in other words, to avoid acting out your dreams, the brain shuts off the motor output from the brain. Even though the brain up here is going through those motor things, it doesn't go out to your muscles, so you don't actually do it. And, it's amazing how God designed such a complex system here to do all of that.
Amen.
And the sensory input. Now, in these deeper levels here, this non-REM sleep, the motor section is not cut off. In other words, it's because we're not dreaming, so we don't need to not act out the dream because we're not dreaming here. But we do cut off the sensory input. In other words, when you're asleep, you're not hearing everything around you. You kind of tune that all out, and it may take a very loud noise to wake you up. Someone may have to shake you. Particularly if you're down in a level 3 or 4 really deep sleep, you're going to take a lot to wake you up. Hey, the fire alarm's got to go off and somebody's shaking you and the dog's barking, get out, the house is on fire or something. Otherwise you sleep right into it too far. So, because we've shut off that sensory, because what the brain is doing right then, it needs that out of the way. And then we get down, as we move down here, these are what they call the theta waves, we're in this non-REM here, and then we start getting this. They're like theta waves, but they get these what they call little sleep spindles. They're like little, every few seconds. And we now even know what those are. And we'll talk about that in just a minute here. And these K complexes, the same thing. They come down in these stages right here, and there's actually information going from one part of the brain to another. We all have, in the very center of our brain, something called the hippocampus. Sometimes called the short-term memory. It's like you took your iPhone with you all day, you turned it on, and you videoed everything you saw, and the microphone was picking up everything you heard, and the thoughts you thought during the day, everything is recorded on there. Well then, at nighttime, we're going to transfer some of that information up to our cerebral cortex. That's where our long-term, permanent, detailed memory is. Say you were learning to play the song on the piano, or you're a kid and you're learning to ride a bicycle. All of that various motor activity is there in the hippocampus because you recorded everything you were doing as you practiced riding the bike or playing the piano or whatever motor activity. At night, these little sleep spindles, if you had a major physical thing you were learning, at night, you'll see those, and they're on the pathways going up to the motor cortex. You're storing that information up in the permanent part of your brain.
Wow.
You might say you're learning it.
Wow.
Because this hippocampus, where we stored it, it can only hold so much. And it's sort of like, okay, for tomorrow we've got to delete all this stuff. And to start off with a clean, fresh drive so you can have learn another day's worth of whatever. You know, you got to record what happened today. And your brain seems to know what to save and what to not save. Like when you go and park your car, when you get out of the store, you can remember where your car is and you go down the right road to it and find your car. But now you don't need to remember where your car was parked today, a month from now, or even a week from now, right? So we delete that information.
Wow.
And you actually have control over what you're going to delete and what you're going to save.
Wow.
The brain kind of learns some of these things. It's like, hey, that's not important, I don't need to. But in tests, they will give people a list of just words to memorize. They have to go through this list of words, and then they'll have them do a sleep cycle or whatever, and then they'll test them on those words. Well, then they did a test where they would give them, as they would go through the words, some of them had a little asterisk by it, and they said, these are the important ones we're going to test you on. And if it doesn't have an asterisk, we're not going to test you on it, so you don't need to. But they would go through the same list of words, and then they'd have a night's sleep, and then the next day, they gave them a test on all the words. And the words that they had said they would test them on, they got very high levels on. And the words they said, you don't need to worry about these, they didn't. In other words, they chose, the brain knew which ones to put up in the permanent memory and which ones to forget about. You know, something like the teachers telling you ahead of time, study this, it's going to be on the exam. Okay, you're going to put that up there. And yeah, don't worry about these graphs of this chapter right here, we're not going to test you on that. And yeah, it kind of fades off and you don't do it. So the brain, you actually can control what you're pushing up there by the attention you place on it, the importance of value you place on it. And you decide what you're actually putting up into that more permanent part of the storage there. But that's part of what's happening right here. This delta activity. When you get to this really, really deep stage, the brain has this massive high voltage synchronized waves of, you might say, discharging going through your brain. This is actually very amazing things because if you think about it, there's all these different parts of your brain, and when you're thinking, what's happening to them? You know, there's electrical impulses here and there, and this one's firing, and that one's firing, and this one's firing. All these different parts are firing, but it's what's happening? It's all random, so to speak. Well, during this deep delta wave sleep right here, it's like if you were at a big football stadium, crowded full of people, and they do this, what they call the wave, and this, people stand up, and as soon as somebody stands up, the ones next to them stand up and sit down, and you get this wave as it passes around, as everybody's, or they'll sometimes have colored cards or something they'll put up, and you make this wave go around here. Well, that's what your brain is doing. Instead of going through the various circuits, it like starts right here in the frontal lobe, and this wave just passes back, and they all discharge like this. So it's going front to back of the brain rather than, you know, through some tractor system that you would think of. It's a totally different type of electrical activity going on in the brain. To just watch this brain in this synchronized pulsation, each one pulsating next to the one next to it, rather than in the various patterns of the circuits for the various parts of the brain. Delta activity, this deep stage, that's when you're that really deep, that's when the brain is restoring. That's when the rest of your body is restoring. That's when growth hormone is put out. That's when your muscles are rebuilding. All of the regenerative rebuilding activity is really taking place during these deep sleep cycle time right here. And if you look at these, you'll notice the very first thing that happens at night is you get a couple of cycles of sleep that go down into that really deep stage 4 non-REM sleep. There's something else very fascinating that happens down there. It's a cleaning process. The brain, all of these cells during the day, they're kind of all this metabolic activity. There's metabolic waste products being excreted by the cells. There's toxins building up. There's all kinds of stuff building up in the brain. Among it, adenosine. As adenosine builds up, you get tireder and tireder and want to go farther and farther into sleep. But all of these different toxins, this is the time we clean it up. And this is just one of the most amazing, fascinating things I have ever heard of in my life, how the brain does that.
Wow.
But if you can imagine a city with big buildings, all laid out in city blocks. There's streets and avenues in a crisscross pattern, and then there's all of these blocks of buildings between all of the streets and avenues. And on this side of the city right here is a river of clean water coming by. And on this side of the city over here, there's, you might say, the drain where the old water can run out to the sea, the sewage, the drain off can go out there. And imagine these streets are really canals of fluid that can pass through there. As you go into this deep level sleep, the microglia, these cells that are assisting the astrocytes and the neurons and all the other parts of it, they all start shrinking. Imagine a city where all the buildings shrunk 60% every night. And as the buildings shrink, the space between them, these avenues and streets, got wider and wider. And so now you've got all these buildings really shrunk down. Of course, as they shrink down, they squeeze more water and toxins and stuff out of them. The streets are full of all the debris and the sewage and the garbage and trash they dumped out all day long. And now we're squeezing the last drops of out there into these streets, these canals. And from the clean river here, perfectly clear cerebral spinal fluid. You ever looked at it? It looks clear as water. Pours out, flows through all of these streets and channels, flows through, just washes them all out into the other river, which flows off, takes it off, out away from the brain. Wow. And so you've got this whole cleaning cycle that goes through there where we just flush the brain, shrink down the cells, widen up the spaces, and just flush it through with this clean cerebral spinal fluid. Wow. And we end up with a clean brain. All of the metabolic waste and toxins all got flushed out and run downstream. Wow. Your liver and your kidney will clean that up later. And we'll make clean, brand new cerebral spinal fluid fresh so that we keep the CSF fresh coming in over here. Wow. And all of that goes through one 90-minute cycle. And I'm seeing that my computer is going to die if I don't plug it in. Okay, we're safe there.
Amen.
just went through a powerful cleaning cycle here. We flushed all of this clean fluid through. And as we come to the end of that delta wave sleep cycle down here, and it goes back up here, all of the buildings expand, all of the cells expand, pushing the rest of the water out. The canals get real narrow and push all that fluid on through and out the drain. So it's almost like pumping action there. And then it goes through another cycle. And we usually do a couple of those deep cleaning cycles during the first few hours of our sleep right there. It's just, I'm just totally amazed how God designed all of this to work. But you end up with a clean brain, first thing. You know, all of these various activities that go on in the brain, probably one of the best examples to understand what's taking place in the brain during sleep is to imagine an office. You've got your business office there, you've got a desktop there, and you've got file cabinets, trash cans, you've got windows, you've got everything you've got in an office, all your stuff right there. And so during the day, you carry on business. Everything you see, people call you, you call other people, all kinds of things take place during that day, and you end up with these papers on your desk. And each event that comes along, you deal with it, and it's there, and everything's on your desktop. Okay, at the end of the day, it's time for sleep cycle. Your brain says, okay, it's time to close down. This is when we're going to go and what do? We close our eyes, you pull down all the shades on the windows, you turn off the ringer on the phone. You're not going to take any more phone calls. Basically, you're shutting down the input, the sensory input there. You're not going to be making any calls. You're not going to be carrying on any of that business during the day that you were thinking about or doing. And what else happens? Well, of course, one thing that happens in every office, the janitors come in at night. What do? Yeah, they're going to clean everything. We just talked about these deep cleaning cycles. So the janitor, they're going to dust and polish and clean everything in that office, get it all cleaned up. But remember we talked about those signals. Well, you're going to go through that piles of stuff on the desk right there, stored there in the hippocampus, and that short-term memory, it's like it's on a little flash drive. You're going to take all of that, you're going to actually sort it out. And some of it you're going to put in your filing cabinet and file it away so you've got it for future use in an organized way. You can recall it tomorrow, maybe next month, maybe next week, maybe a year from now. You know, in other words, if you file it well and have it organized, it's going to be there and you can get it back later. Whereas other stuff, there's a trash can and you're going to throw those papers in the trash can. And by the time you go through these other cycles right here, you have been cleaning those. And then you take, like, if you go store, like you think of your short-term memory as like a little flash drive, well, let's delete it, you know, clean it, wipe it clean, get all the data off of it, so that tomorrow morning, you got a clean flash drive there for recording everything of the next day. Isn't that neat? It's just amazing how God designed that to work. And so you can go through your next day, take care of everything you need to. You can go back to your file cabinet and pull stuff out if you need it. And everything is just going to be turning out great. What about REM sleep, where you're dreaming? It was a mystery as to why we had REM sleep, but we can learn a lot about it by what happens if you deprive people of REM sleep. But what we're learning is REM sleep is creativity. This is where the brain is making random connection, this thought with this thought, and this idea with this, rearranging this stuff. There is a interesting story. If you've studied chemistry, you're all familiar with the periodic table of the elements and how they're lined up and how it matches electron shells and everything. And if you've taken a chemistry class, you had to memorize that periodic table of the elements. Well, we didn't always have a periodic table of the elements. There was this Russian chemist, and he said there's got to be some order and pattern to, you know, chemistry. And he made up these little flashcards, like, and on each card for each particular element, whether it was oxygen or carbon or lithium or whatever. He had everything we knew about it, you know, all of its different details and stuff. And he would, when he was traveling and whatever, he'd pull these cards out and try to arrange them and look at them. For a year and a half, he kept looking at those and thinking about trying to get them, what was the order and the sense of these. One night, while he was traveling, he was deep in sleep, and he came to his dream, and he was dreaming. And in this dream, he lined them all up, and they made perfect sense. Yes, that's it. That's, you know, the electron shells and everything all came together, and he woke up from that dream and immediately pulled out his cards and laid them down and looked at them, and yes, that was it. And he wrote that down, and that is the periodic table of the elements as we have it today, with very minimal changes from what he put together during REM sleep. The brain organized it for him during that time. There's been many stories of composers and, you know, people that, songwriters, who did put together their poetry or music. They'd wake up from a dream, it was right there, and they'd quick write it down and down, you know. I know this one, he would always keep a little recorder, you know, a little, back when they had cassette recorders, and by his bed, he'd wake up, and if he had, you know, he would grab his guitar and start, you know, and out and put it out, and then go back to sleep. Next morning, it was, wow, that's cool. He didn't remember that at all. But his brain had put it together during there. So creativity, organization, those type of things are all going to come during that REM type of sleep. They add that other dimension to life that we're capable of, that beyond just, you know, rote memory and control like a monkey would do, or your dog. We're capable of much more. And the REM sleep is when we put much of that creativity together. So those are the parts, those are the type of things that are going on there. And I think that office thing of what you do during the office at night and day, you see, what happens at night is just as essential as what happens during the day. But yeah, these are the picture of those little signals where they brought the messages, the information is going from the hippocampus up to the cortex, where it's permanently stored there. Whales, interestingly, sleep with half of the brain at a time.
Wow.
What would happen if you paralyzed your muscles and you were a whale? I mean, whales have to keep coming to the surface and taking a breath of air.
Yeah.
If you paralyzed him during REM sleep, he would drown.
Wow.
And so here you can see the patterns here. Half of the brain is going into sleep right here. The other half is awake. And then partway through the night here, oh, we switch over. Now this half is awake and this half is sleeping. And so the awake half controls, and so you can keep coming up and taking your breaths of air and doing the things you know, unparalyzed. And the same with the other half. You can get your sleep in that way. It's really amazing. This picture down here, these are sperm whales. They sleep in a vertical position. They kind of come up to the surface and get the breath of air, and then they kind of settle back down. And it's a vertical up and down thing while they're sleeping doing that. It's amazing. These little days, I told you those spiders, I just found that when they hang upside down on a thread and do their sleeping on there. Birds sleep with half the brain at a time. Have you ever seen a bird sitting there and he's got one eye closed and one eye open? He's taking a little nap with half the brain. The other half is keeping an eye open to make sure he doesn't miss out on anything that's going on.
Wow.
You know? And well, the interesting thing is, if you get a flock of birds and you put them together on, notice right here, see how they're all together sleeping, all snuggled up against each other? Well, what they will do when they're snuggled up together like each other, all the birds in the middle sleep with both halves of the brain at the same time. But the bird on each far end sleeps with the outside half of it awake and looking out here, and the one on this side has this half of his brain looking out here. So they're each looking off the two ends of the things, and so they're sleeping with half a brain, but the ones in the middle are sleeping with both halves. They're saying somebody else is watching from out there on the edge.
That's amazing.
And then in the middle of the night, the birds on the end will kind of get up on their perch, they'll turn around so that the other eye is facing out, and then they'll sleep with the inside one will go where half of the brain can sleep, and the other side is now watching out. Isn't that amazing? I'm just totally amazed at God's creation.
Hey, isn't it?
There's all these little things right there. Seals, when they're out at sea, they'll go out to sea for sometimes months at a time catching fish, and then there's times they'll come in where they're just sleeping on the shore, every time. Interesting, seals don't have any REM sleep when they're spending this month or two out at sea. But then when they come back and they're sleeping on land, then they get lots of REM sleep. They get this huge amounts of REM sleep. Babies start sleeping while they're in the womb. A baby that's born spends maybe 20 hours sleeping. You may have 4 hours, 2 to 4 hours where the baby's actually awake. Other times the baby's sleeping. And babies run, not that like cycles like I showed you there, they're running 50% REM sleep. REM sleep is not only when you dream and do this creativeness, but REM is also when you grow new neurons and new neuron connections. This brain's neurons connecting to this one, to this one, to this one. That's happening in those times. That's why it's so important for our children to get that REM sleep. That late morning sleeping in is actually allowing them to make those other connections as gauged by what they've been learning and thinking and doing, during the day. But so we don't want to cut out and lose that REM sleep there for them. But babies, the brain is really growing there during those first couple of years and have a huge amount of REM sleep. And REM sleep is when it's putting out all those new neuron connections and making all those new synapses and everything that's going to make the brain they're going to be there. Caffeine. We often use caffeine to deal with sleep deprivation. As an ER doc, I can tell you, you're up all night, you have to keep going. Something's coming in, you got to keep going. But it comes at a cost. What does caffeine do? We take caffeine and, we're awake. Okay, I don't need to sleep now. I can stay awake because I've got some coffee or a Dr. Pepper. Here's a chart that shows right here this awake and asleep. And this is what they call this sleep drive here. In other words, and what it is, it's a substance called adenosine. When you're awake, you start building up adenosine in the body, okay, in the brain. And as the adenosine builds up, you're going to be more and more, once you get up here, I can take a nap, I'm getting tired. And as we get up here, of course, when we go to sleep, we need that adenosine to sleep. It's actually what puts us into the sleep cycle. It makes us feel sleepy, it puts it in, and there's receptors for adenosine on our neurons. And when you get enough of those saturated, you can go into sleep cycle, and you need those there. If there's no adenosine, you can't actually sleep. So you need that adenosine building up there, and that's what makes you tired and the need to sleep right there. And then, of course, the melatonin comes in and says, it's okay, go ahead, guys, do it. And you switch over into the sleep cycle. But it's the adrenaline that is doing that. You might say the counterbalance of that is cortisol. Cortisol is that I feel awake, top of the morning, let's be awake, we're in the awake cycle now, we think now, we don't sleep. And sort of like in the morning, starts off and it quickly builds up, and it's like the music is really loud and then it fades off as the cortisol level drops at night. And of course, adenosine is the opposite, it's building up. And as it builds up and the cortisol is down, now we're in our we need to sleep cycle. So these are some of the hormones that control that. Well, now take a look here at this is the structure of caffeine, and this is the structure of adenosine. And notice this part right here and this part right here have a lot of similarities. And there's receptors for adenosine, okay? And these adenosine receptors, as they get full, now it's going to be time to sleep. Well, caffeine is enough like adenosine that it can go to an adenosine receptor, and the caffeine can stick into the adenosine receptor, but it doesn't do what adenosine does because it's not the identical one. So it blocks adenosine, but it doesn't allow you to sleep. And so if you take a whole bunch of caffeine, it displaces this adenosine, and so now you don't have the sleepiness, and you can't go to sleep because the caffeine has displaced all. So that's why caffeine is keeping you awake, because it's pushing all the adenosine off of these receptors, and it's sticking on all these receptors, and it doesn't do what the adenosine does. And then if the caffeine wears off, but caffeine's got a fairly long half-life, so I think 7 to 14 hours, it varies depending on your ability to metabolize it. But, and you figure to get 90% out, well, that's 3 half-lives, so it can take most of the day. So particularly caffeine taken in the afternoon will be there when you go to bed. And you're not going to have the same amount of adenosine and the same ability to go into and do what cells need to do to sleep, to be in this sleep state. It needs adenosine and these receptors turning on the sleepiness. Here's a picture. The top 3 pictures right here are brain scans of a normal brain, and you can see here where it's all lit up. That's the adenosine triggered normal sleeping of the brain. See how brain, in other words, remember, sleep is not doing nothing. Sleep is a very active process. The brain is doing all of these things we've been talking about. So this is what the brain looks like during sleep when the adenosine, all of these cells are doing these things. During the day, there'll be a spot here and a spot here, depending on if we're playing the piano or doing some math or just relaxing and talking to friends or whatever. The various parts of the brain are doing their various things. But of course, during the sleep cycle, we've kind of got this all turned on because we're doing all of these housekeeping things, whether it's the deep sleep cycle cleaning and growth, if we're growing new synapses during the, or whatever it is that we're doing there, transferring stuff up to the cortex, all of that's going on here. Well, here is the same brain with caffeine. And so here, I think they gave them like a tall coffee right here. And look at all of what happened to the brain activity there. See how it's all shut off? So if you think about that, the caffeine only keeps you awake, but it stays on there. And as it stays on there through the night, the brain can't do what it wants to do and needs to do during a normal sleep cycle because we've shut off the adenosine receptors, and it needs those adenosine receptors turned on to do the sleep things it does.
Wow.
Remember this picture right here of the various sleep cycles? Okay, now compare that with this next picture. This is the brain on caffeine.
Wow.
So look at all of these brief awakenings are micro. You may not wake up and realize you woke up, but the brain is going back up to a wake cycle here. And then back down. And notice how deep it's going. 1 or 2. Where's that deep stage 3 and 4 sleep here for those first couple of cycles of the night? They're gone.
Gone.
The deep cleaning that your brain needed, it's not getting here on caffeine. And all of these other really important deep cycle activities are not taking place at all. And when you wake up the next morning, are you going to be as clear-minded as you were before? No. You're not going to feel good. There's still going to be, remnants of adenosine out here, and now that the caffeine's finally depleted here, you're going to be groggy, and the only way you can get going in the morning is to have your morning cup of coffee to knock those adenosines off, because you didn't get them flushed out at night because you didn't have the deep sleep cycles here.
Wow.
See that right there? In other words, so without the deep sleep cycles here, you're not doing that deep cleaning, so you're not washing all of this stuff that's in this room. And so by morning here, there's probably still a lot of that adenosine, and now I can finally go stick on those, and so now you're starting off the day where you would be in the afternoon or evening. You're tired. And the only way to get going in the morning and keep going is to put in another dose of caffeine and push that adenosine off so we can do our wake cycle stuff.
Wow.
Because the adenosine makes that hard. You see why we've been advised to stay off of tea and coffee and sun? It's really messes up a very, very important part of the life. So important that God says you're going to spend a third of your life unconscious to do these activities.
Wow.
It's that important. A good 8 hours. And the people say they do fine on 6 and 4 hours of sleep. They've learned a way to adapt and get by, but they're not doing the same. They are having the same effects of sleep deprivation that someone else is. Your brain actually needs that, your adult brain needs that 8 hours. Of course, the baby's brain needs 20 hours, but, What about sleeping pills? I can't sleep. And we can get some Ambien or some Ativan or, some various sleeping pills. What happens when you take a sleeping pill to your brain cycles? Well, sleep isn't just not being there. It's not just being unconscious. When you go to the operating room and the anesthesiologist gives you an anesthesia so that you don't feel or react to the surgeon's surgery that he's performing on you, he gives you an anesthesia. That anesthesia is drugs, or a combination of drugs that act on the brain, and they turn it off. But your brain is not sleeping during surgery. It's shut off. It's not awake and it's not in sleep. It's turned off.
Wow.
If you think about it, anesthesia is sort of poisoning short of death. And then that's why the anesthetist is supposed to be 100% in attendance there at the head of the bed for the entire surgery, paying attention. It's not he gives a shot and goes off and does something else. And he needs to be there paying attention to everything that's going on to keep you right. And he's got various sensors he's using to tell if you're at the right level of sleep. And the surgeon can tell if the patient's moving a certain amount, what he needs more of. And so it's a very delicate and complex thing to give enough to put you out so you can comfortably go through the surgery and not react to the surgeon's interventions. But the brain is not sleeping. It's just basically poison, so the cells aren't running. They're not awake, they're not asleep, they're not anything. They're just kind of, you might say, sedated. They're sedated. Sleeping pills are just another form of the same thing.
Wow.
They're not quite as strong, as the drugs the anesthesiologist is giving you, but they're basically some of the same kind of idea. We're giving drugs that turn off the cells of the brain.
Wow.
So while you won't be awake, you're not doing sleep. All these important things we talk about that happen during sleep are not happening on sleeping pills.
Wow.
So the answer is not the sleeping pills. What about alcohol? A lot of people, a glass of wine at bedtime, a nightcap, something to put me out. I sleep better, I fall asleep better, I sleep better if I've had my glass of wine before bed. Alcohol is a brain poison, and it shuts off the brain just the same as, we talked about the sleeping pills. One interesting aspect of the alcohol shutdown of the brain is it totally, even at low levels, shuts off REM sleep. A brain on alcohol is not dreaming. And even very low levels of alcohol is not dreaming. One of the things, as an emergency physician, I often get alcoholics that are in withdrawal. For whatever reason, they don't have alcohol, whether somebody's told them they have to stop and they're stopping, or they just didn't have the resources to buy any more, get any more alcohol. So they're out of alcohol, but their brain is very adapted. Well, for the fact that they're an alcoholic and have been on alcohol continuously for weeks or months or whatever period of time right here, they've been going without REM sleep during that time. And as the alcohol wears off, and now they've got no alcohol preventing the REM sleep, it's like the brain says, at last, REM sleep, let's do REM sleep. And the brain is going into this powerful dreaming REM sleep state, so much so that it will go into REM sleep while you're still awake. We call it hallucinations. They're seeing somebody in the room that's not there talking to him, and they're seeing somebody here, and there's snakes crawling across their bed, and there's spiders crawling up the wall. And it's a very dysphoric thing because they're in the alcohol withdrawal, but it's, and I don't know why it is, but snakes and spiders and creepy things seem to be part of their hallucinations that come on very strongly with this alcohol withdrawal. So with the importance of REM sleep, you really don't want to shut it off with a glass of wine at night to help you go to sleep and sleep better. It's, God designed it. It's a very complex mechanism, and we really don't want to mess with it.
Amen.
Clean water, healthy food, and take your sleep cycle. Sunlight and exercise during the day will help get your body ready so that it's also ready. If you're just doing stressful brain all day long, your brain might be totally exhausted and want to sleep. But if your body hasn't had a good workout too, and physical exercise, the muscles, I'm not tired, I know that, why are we doing sleep now? It's nice if you coordinate that. So there's a time for work during the day, physical, muscular work of some kind, and mental work, and now it's time to go to sleep, and everything's coordinated and going to go to sleep better.
Amen.
Quiet, in other words, you're helping your body, trying to shut off the sounds coming in. A very dark room, you're hoping to cut off the light coming in that might interrupt it. Cool, remember how the body's temperature drops at night? I think they've calculated 68 degrees is the ideal room temperature for sleeping.
Wow.
I mean, you still have your sheets in bed, but that's cooler air seems to be the best. So those are, you might say, the ideal circumstances. A brain free of caffeine and other drugs, and if need be, some melatonin supplement if you're not making melatonin now, like a lot of us aren't. I take melatonin every night.
Wow.
If you'd like to read some more, this book, Why We Sleep by Matthew Walker, is a fascinating book that anyone can read. You don't have to be a doctor to read it. This is a popular reading book. But he is one of the foremost scientists that's actually figuring out all this stuff about what the brain is doing and which part's talking to which and which has happened. And with a lot of very fascinating stories, he's explaining what's going on in the brain during these sleep cycles and sleep times. And I highly recommend it if you're interested and fascinated and would like to know more about it. The delicate nerves of the brain are the only channel through which God communicates with man. Our brain is really important. Outside of your brain, you have no relationship with God. Christ in you is Christ in your mind. When he talks about, I'll give you a new heart and a new mind. I'll write my laws in your heart and in your mind. All of these different descriptions, we are the temple of God.
Amen.
This all takes place in those delicate nerves of the brain.
Wow.
You know, so stay away from the alcohol, the caffeine, live a clean life, and then you'll have the best possible thing, and God will come and work with that. And remember, sanctification is not working harder. Sanctification is God in you.
Amen.
It is God's presence in you that sanctifies you. And God's presence in you is dependent upon your surrender to the Holy Spirit.
Amen.
As you surrender your life and everything in it to God's will as best as you understand it, God will come in. You read all those promises, they're always, I will write my laws in it. I will. It's always God promising something He's going to do.
Amen.
Sanctification is God's presence in you, Christ in you. That's the key to it. And it's something He will do in you. But it takes our willingness. There is a surrender, an absolute surrender. And that's the key to it. And understanding sleep and the effect of drugs on the mind is a gift that God has given us to help us understand and cooperate with Him. To do everything He can to help us along this way that we can be in Him and He in us. The temple needs to be cleaned.
Amen.
And our brain needs to be cleaned. And we need those deep cleaning cycles so that our brain can be sensitive to the messages that God will give us.
Amen. Thank you, Doctor.
I hope you all get a good sleep tonight.
Yes. Thank you.